بسم الله الرحمن الرحيم. تعالوا نقول في الأول أهلا بكم في سلسلة جديدة من سلاسل النيوروأناثيزيا. آه المرة دي إن شاء الله بنبدأ سلسلة عن الفيزيكس in anesthesia or physics necessary or essential for anesthesia. الحقيقة آه هي في مقدمة كان نفسي أقولها إن بالنسبة لي الفيزيكس ماهيش موضوع سهل قوي إن أنا أتكلم فيه بصورة منهجية أو بصورة تعليمية. إحنا كنا بنحاول نفهم الكلام اللي موجود في الفيزيكس وحاجات بتتحفظ، حاجات بنفهمها، وبعد كده بنحاول نطبقها إذا قدرنا على الأجهزة اللي معانا والكلام ده، وإذا كان في امتحان بندخل الامتحان. لكن الحقيقة كتير منها ما كانش بيبقى ثابت، وبناء عليه صعب إن أنا أدي فيها محاضرات أو أسجل فيها فيديوهات لغاية ما لقيت يعني هنقول تعريف للفيزيكس الأول. الفيزيكس is the foundation of safe anesthesia. دي حقيقة because it governs how anesthetic machine vaporize volatile agents. So vaporization and the use of vapor of the anesthetics will depend on your understanding of how you are going to vaporize, or your machine is going to vaporize this anesthetic fluid to give it vapor as a vapor for your patient. Mechanical ventilator manage gas flow also is very important to understand the underlying physical principles present in the work of this ventilator. A very important part, very important topic in our anesthesia. Monitoring equipments, actually, just like pulse oximetry, ECGs, EEG, and all other monitors that we are going to use during anesthesia and anesthetizing our patient. How do these devices work or operate? It depends on, or it requires the understanding of the physical background of this device, actually. Also, understanding these principles, the physical principles, ensures the precise drug delivery, how and what dosage you are going to use in your anesthesia. Depends on physical background, by the way. Also, to ensure optimal respiratory support also depends on our understanding in for some physical laws or rules. Electrical safety in the operating room, very important to understand that principle as well. تعالوا نرجع للمقولة اللي هي خلتني أحس إن أنا ممكن أتكلم أو أدي محاضرات في الفيزيكس أجين بعد فترة طويلة من مذاكرتها وقرايتها وحفظها. هي مقولة قالها the famous physicist or the famous scientist Einstein. Actually, he said that if you can't explain it simply, you don't understand it well enough. واضح الكلام؟ يعني لو أنا ما قدرتش أفهمكم الأجزاء المهمة اللي في الفيزيكس اللي احنا محتاجينها كأنثولوجيست، ده بيعني حاجة واحدة بس، إن أنا ما قدرتش أفهمها لنفسي الأول، وبناء عليه احنا قلنا إيه؟ نبدأ الفيزيكس، نبدأ principles of physics that we need in our job. First of all, to try to understand it well, to be able to apply and to give videos or lectures for you to understand these principles. Subjects that I'm going to talk in this introduction, consider this video as an introduction to physics. I'm going to talk about the atom, structure of the atom, states of the matter, as well as the phase diagram. So let's start with the atom structure. But as a word, atom actually comes from an old Greek word meaning indivisible, meaning that it's something that cannot be divided, meaning that at a time they thought that the atom is the smallest part, the smallest particle present in any object, that you cannot divide it into smaller objects. This is the meaning of the atom as a word. But in 1912, the scientist, the famous scientist, Ernest Rutherford, began to talk about the atom and caused a sensation that the atom is divisible. We can divide the atom itself into smaller particles, smaller, say, yes, particle is okay. The mass of the atom is concentrated in a tiny positively charged nucleus. This is a description given by Rutherford, by the way. It is a tiny positively charged nucleus surrounded by a tenuous cloud of negatively charged electrons. So we have a positively charged nucleus inside, and we have negatively charged electrons around this nucleus. This is the structure, or let's say the classical structure of the atom. So he constructed the Rutherford model that we can see here. It is called atomic planetary model. Actually, he describes the atom as if being a sun with planets surrounding this sun and moving around it. This is the theory, or this is the description of the atom according to Rutherford. Electrons represent the planets. So electrons around the nucleus, just like the planets, orbiting the nucleus, which present the sun. So this is the sun, or the nucleus, surrounded by the planets or the electrons, negatively charged electrons. Planets are drawn to the sun due to gravitational force. Here is the difference. The planets are attracted to the sun as a result of the gravitational force, as being each of them, the planet and the sun, have certain mass. So these different masses are attracted together. This is well known in physics. But the attraction for the atom is due to the electrical charges. Positively charged nucleus attracts the negatively charged electrons. So this is the difference between the actual galaxy that we live in, meaning that there is a difference between the attraction between the sun and the planets, because it is attracted to each other by the gravitational forces. So we are talking about the force. Just remember this word. While in the atom, the attraction between the nucleus and the electrons depend on the electrical charges present on the surface of each particle, the electron and the nucleus, positive and the negative, so they are attracted to each other. The nucleus of the atom has protons, bodies, particles called protons, and neutrons, other particles, and both have approximately the same mass, the proton and the neutron, comprising or forming the nucleus. Protons are positively charged, while neutrons have no charge. So the positively charged uh, are covering the protons. So the protons give the charge, the positive charge to the nucleus, while the neutron, no, it is not charged. It is neutral particles. The number of protons defines the atomic number. So if I have an atom having two protons, its atomic number will be 2, as simple as that. And actually, it may uh, thought of the atomic number as the fingerprint of an element because it is fixed for a specific element. Meaning that if I'm going to talk about an element, any substance, just like say sodium, say hydrogen, whatever, uh, all the atoms of this element will have the same atomic number because it represents the fingerprint of this element. No difference between an atom from the other atom. The same atomic number. While the total number of protons and neutrons almost exactly equal to the atomic mass. So we have two numbers, the atomic number, this is fixed for each element, while protons and neutrons present the atomic mass. Atoms of the same element can have different numbers of neutrons. This is very important in their nucleus and known as isotopes of the element. So the element may have different mass number. That's why we have many isotopes in the same element. This is an example showing the difference between two isotopes of helium. We all know the helium. Actually, we have one isotope having um, three elements, three particles in the nucleus, one neutron and two protons. So this is helium 3, while helium 4 has already uh, it contains four particles in the nucleus, two protons and two neutrons. Bohr model and the energy levels, or sometimes they say Bohr modification of Rutherford model. Anyway, Bohr is a Danish physicist, well known actually, incorporated the idea of energy levels into a new atomic model. So this was the first time someone talks about the energy levels of the atom. This was the Danish Bohr. Electrons could only exist in defined energy levels, and they could jump from one level to another level. So we have many energy levels, or they call it, I think, shells, as will be mentioned later. The electrons are arranged in these shells, in these orbits. Each orbit, each shell has its own level of energy. Electrons live in one of these shell. As I have mentioned, each shell has its own energy level. These energy levels are organized into shells, as I have mentioned, around the atom. Another something that I like to mention briefly, the chemical bonds. What are the links present between different atoms in different elements. What combines the different atoms of, for example, of water, of air, of any metal, of iron, of brass, or anything. These are called the chemical bonds. The attraction between atoms is known as the chemical bond, as I have mentioned. There is a lot of bonds actually known in literature or in science, but there are four major types usually mentioned as types of these chemical bonds. These types are, the first one is ionic bond. This is the most powerful bond. Actually, in this bond, there is some uh, electron, they call it valency, yes, valency electrons actually, the electrons in the outer shell, transferred completely from one atom to another. That one atom that lost the electron, between brackets, negatively charged, will be positively charged ion, while that one that accepted or gained these electrons will be negatively charged, meaning that here we have two ions. That's why we have cations, positively charged, and anions, the negatively charged. Example for this bond is the bond between sodium ion and the chloride ion to form the sodium chloride. Very known example. Just it represents actually the salt, the ordinary salt that we have. Covalent bond is another bond that we can talk briefly about it. Actually, the covalent bond is formed when the electron pairs between atoms are shared. They are not lost from one atom to another. No, they are shared between the two atoms. They may orbit or move around the nuclei of both atoms. So they are completely not transferred, but just shared. For example, the oxygen molecule, the two atoms forming the oxygen molecule. Another one of these chemical bonds, a hydrogen bond. We can see it here in this picture. Actually, a hydrogen bond can be defined as the attractive force that binds one molecule's hydrogen atom with the electronegative ions like fluorine. Because hydrogen atom will be positively charged, attracted to electronegative atom, as we have mentioned, just like fluorine, chlorine, bromine. Also, all these negatively charged. For metallic bond, this is the fourth one that I'm going to talk about. The metallic bond, the collective sharing of C of valency electrons, a lot of electrons present in between and around the atoms of this metal, amongst many positively charged metal ions, is referred to as metallic bond. This is the fourth one. So we have four types. The major types of bonds. We have other bonds. Yes, we have a lot of other chemical bonds that may be mentioned in literature. States of matter. See, these bonds and the type of bonds and the tightness of these bonds actually help generally in forming the state of a matter. The way atoms interact with one another determines the properties of the matter. Interatomic and intermolecular bonds both determine the bulk properties of the compound, including whether it exists as a solid, a liquid or a gas at a given temperature. And remember this word, please, for me, the temperature. So the bonding, the attraction of the atoms uh, makes a difference, or actually this is the main issue that determines the state of the matter being at this temperature that we are measuring in, being solid, liquid, or a gas. So these are the four states of the elements, whether solid, liquid, gases, and plasma. We'll talk about plasma later, but let's say that solid have rigid bonds between their molecules. Example, the ice here, contained here, as we can see, this is the ice present in a solid state. We are going to warm this ice to have the water, the liquid, having looser bonds. We have changed the temperature. So we changed the status of our element from solid to liquid. In gases, actually have minimal uh, bonds, because if we are going to heat this water, it will go into vapor status. So these are the three status that we mentioned: solid, liquid, and gases. The fourth status, the fourth state of the element is the plasma, as we can see here. The fourth one, yes, to the right. This is the plasma status. Anyway, the fourth state of matter, as we have mentioned, actually, it is a gas-like mixture of equal numbers of positive and negative ions, making it electrically neutral. So this is electrically neutral status. It is created at very high temperature, just like the sun, for example. The resulting high energy ions form the plasma status. This is very important, because actually we were not so oriented with this status. We usually say that we have either solid, liquid, or vapor, or gas, say gas, but we don't remember, or let's say that I didn't know the plasma status until very recently, actually. Anyway, let's talk about heat and energy status of the matter. I have mentioned heat and temperature many times, and that I told you, just remember that, because actually heat or temperature is very important in our physics and its application in our anesthesia. So let's say that heat capacity for an object, uh, it is needed to increase the temperature. So energy in the form of heat must be added. So just for an object to increase its temperature, energy in the form of heat must be added, just to change the temperature of our element. Anyway, the specific heat capacity of a substance, certain substance, determines the energy needed to raise 1 kilogram of a substance by a temperature of 1 degree centigrade. This is the specific heat capacity, or say it, specific heat. Latent heat, another definition that we need to know. Actually, it will be mentioned later on, maybe with vaporization of our fluids or so. Later on, it will be mentioned, I'm sure about that. Anyway, latent heat, they say that to change a matter state, energy must be either added or removed, and this energy is referred to as latent heat. So the latent heat of vaporization, this is an example, is the energy required to boil 1 kilogram of liquid to change it to vapor. So we change the status from water to vapor. This is the latent 1 kilogram, only 1 kilogram. This is the latent heat. Phase diagram, this is very nice, by the way, very nice diagram. That's why I wanted actually to show it to you. We have mentioned before that the three states that of matter that we can talk generally are solid, liquid, and vapor. Phase diagram is a graph that displays the relationship between the solid, liquid, and the gaseous status or states of a substance as a function of temperature, volume, and pressure. So this is a complex diagram showing the three states of the matter under certain temperature, volume, and pressure. Each substance has its own phase diagram. So this phase diagram is special for certain element, for certain substance. You cannot apply it to all the materials, all the matters, all the elements. No, each element has its own phase diagram. Example, water turns from liquid to gas as it boils at 100 degrees centigrade, and from liquid to solid as it freezes at 0 degrees centigrade. See, we have mentioned the temperature here because this is very important. These temperatures only apply to substances at one particular pressure, atmospheric pressure at the sea level. This is usually used. I hope I am clear. If the temperature and the pressure are known, if temperature of this element and the pressure present are known, then phase diagram can be used to predict what state a substance will be in. Meaning that if I'm going to have an element, a substance, and I want to see if this material, if this element I'm going to say to produce a temperature around 0 or minus 14 or minus 50 or whatever under certain pressure. If I'm going to see this diagram, I will be able to say that this substance at that pressure and temperature will be a liquid. It will not be a mass, a solid, or a vapor. For example, the point where all three states, solid, liquid, and the gas, intersect is referred to as the triple point. So this is the triple point, very important for the production of this diagram. So this diagram is very important actually. And finishing talking about this diagram, we have finished the introduction to the physics in anesthesia or for anesthesiologists. I hope next week we'll talk about another subject that I think it will be very interesting for you and it will be very beneficial, inshallah. I hope this subject will be interesting and it will be as easy as possible. Anyway, thank you very much and goodbye. I hope to see you next week. Bye bye. Salam alaikum.